Okay, parents, this video is going to be another multiplication video about doubling and halving. Right now, we have two arrays, okay? And with this strategy, students should be more aware and have practiced using arrays and realizing what they mean conceptually, visually. So with these two arrays, I can ask a student, how are they similar? They should recognize that these arrays are equivalent because they equal the same sum. But more importantly, they should realize that we are able to manipulate the movement without changing the value. So if we wanted to split, if we wanted to move this one, the one on the left, which is a 4 by 6 array, we can move it down the middle, split it down the middle, and move it like this. And now they are a little like lopsided, yeah, but these arrays are now very equal in shape, in distance, not a distance from each other, but like, I guess how by 3 columns, that they are now separated into 3 columns, and 8 rows. So the one on the, if we move it back, now we can look at the one on the right, which is a 8 by 3 array. And if we split this one down the middle, because we are having it, we can move it to the left or the right and make the exact same array that we have just looked at on the left, the 4 by 6 array. And now we have a 4 by 6 array as well, after looking at it and moving it from an 8 by 3 array. So they have the same value no matter what. We have doubled the look, or doubled the movement in the left array, from a 4 by 6 to an 8 by 3. And then we halved this 8 by 3 array into a 4 by 6. It looks like it's smaller, looks like it's more compact, but it really isn't. It's the same array, it has the same value. Okay. So yeah, like I said, nothing was changed except the placement. And we can do this for more values and expressions that seem messy as well. So if we have and this is just a visual representation of a 4 by 6 and an 8 by 3. So let's move this one back. Then 8 by 3. So if we have 4 times 6 is equivalent to 8 times 3. Why? Because 8 is half, or sorry, 4 is half of 8, and 6 is doubled of 3. Excuse me. And then if we do this problem, 45 times 24, we can't double, or we can't have the 45 because it just doesn't work out evenly, or doesn't reduce evenly. but we can double it. So if we double it, we would get 90. And we can have or reduce the 24 to get 12. So now we have 90 times 12. And we can keep reducing it until we can't reduce it no more. So let's do, if we were to reduce the 90, we would just end up again with the same problem, 45 times 24. So if you double one number, you need to double it again. And if you halved one number, you need to halve it again until you can't have it, until you can't reduce it anymore. So if we have 90 and we double it, it becomes 180. And if we have 12 and reduce it, we have 6. And if we can reduce 6 again, so if we double 180, we get 360. And if we have 6, then we get 3. So now we can look at this problem. We can do it as an array, but it would be too much. We can look at it as a number line. I don't have a number line that is long enough for this, but I can definitely draw it out. So we have 0, and then we will have to jump. 360 places 3 times. So we have 0, and then 360, and then we have 720, and then 1080. Okay, so if we jump, here's 1, here's 2, here's 3. We just hopped 3 times,